q, that's coordinates are given 0, 1, it's equidistance. That means the distance from the remaining 2 points is supposed to be equal. And you have been given 2 points P and R. What are the possible values of X? Remember, they say values, so that means there is a chance that you will get more than one value. That happens because the distance formula involves square. So when you take square root, there is a chance of considering positive as well as negative square root. So you can get two values too. So you have to be careful for that. Also find the distance QR and PR. Let's quickly draw a diagram. Let's assume that this is point number 1, P, 5, comma, negative 3. And let's say this is point R, X, comma, 6. Let's join the line. And there exists another point Q, which is 0, comma, 1. We don't know how far it is, and that's one of the questions. They have been telling us that the distance, this Q point is equidistant. So that means it is at the same distance compared to P and R. So if you join a line joining P and Q, that distance will come out to be, if you have a line joining Q and R. So these two dotted distance are same. That's the meaning of equidistance. We know the distance formula. It's x1 minus x2, the bracket square, plus y1 minus y2, the bracket square, and everything under square root. When we consider PQ as a line segment, this distance can be calculated. Well, at that time, we will consider this x1 and this y1. And that time, Q, the coordinates of Q, will be considered x2, comma, y2. And eventually, when we are considering QR, let's keep this as x2, y2, and we will consider this as x1, y1. So we will be able to calculate this distance. So now we have to plug in the values, these two values, these 4 values in the distance formula to get some distance, and equate that distance by plugging in the values from this side. Let's see how that works. 5 minus 0, because that is x1 minus x2 square, and negative 3 minus negative 1, that is square, everything under square root. That will give you this side. And let's repeat that process on the other side too. X minus 0, the whole bracket square, and 6 minus 1, the whole bracket square. Well, we can square both sides and get rid of square roots right at the beginning. And I will keep only the terms under the square root as they are. We'll get rid of the square root by squaring both sides. 5 minus 0 is 5, minus 3 minus 1 is minus 4, x minus 0 is x, 6 minus 1 is 5. Let's square these terms. 5 square is 25, negative 4 square is 16, x square and 25. 25 can be cancelled, x square comes out to be 16. So let's take square root of both sides. Now we have to consider positive as well as negative root. So that would be x equal to plus or minus 4. Now, that will be the possible values of x. We got 2 possible values, positive 4 as well as negative 4. Now, it doesn't matter whichever value you substitute. Remember, these two are equidistant anyway. So either one distance you can calculate and say that the other distance is same, or simply plug in plus or minus 4 directly into the distance formula. When you square that, that plus or minus will get disappeared easily, because when you square plus or minus, irrespective whether it is plus or minus, the square will be always positive. So this will come out to be plus or minus 4, and 6 minus 1 is 5. Plus or minus 4 square is 16, positive 16, and 5 square is 25. So eventually your answer will come out to be, this should be 16, my mistake. 25 plus 16 will be 41 units under square root, and that will be your final answer.